same value, right? Let's work that out. So the limit as x goes to 3 from the right of f of x is equal to what? What's the formula? If we're to the right, we've got the 2x plus c formula, right? So plug in 3, we get 6 plus c. On the other hand, the limit as x goes to 3 from the left of f of x is given by the other formula, x squared plus c. And as you guys were just telling me a second ago, that gives me 9 plus c. Whoa. Is that right? I've made the problem impossible. Did you guys see why? You see, the thing is, guys, if you look at the problem that's in your homework, you don't have a plus c on both of them. Anyway, the c has not been, the way I put the c, it's made the problem impossible. All right? Because, like, graphically, what's going on here is, you know, you've got, basically, you've got this x squared. Let me put down here. You got, so, like, this would be x squared. Right, and then you got 2x. But the thing is, they wherever they cross, it's like this would be for c equal to 0. Anyway, the answer at the moment, can you solve both of these at once? Can you put these equal? If you put these equal, you get 0 equals to 3, which is impossible. So the answer to the problem as it's stated is it's impossible. So no solution. F of x as given cannot be continuous at, x equals to 3. And if it can't be continuous at 3, that means it's not a continuous function. So how can we fix this problem to make it work out better? How about this? Instead of, so I'm just going to make the corrections with a different color, guys. So, or maybe correction's the wrong word. Modifications. I'll use green to make my modifications here. So let's just cross out the C. In this case. All right. So if I do that, that crosses this out and this out. F of A is just 2A, right? Cross that C out. This just becomes 6, right? Everything else is the same. And so then we'd have the equation 6 has to be equal to 9 plus C, which would tell me that C has to equal to minus 3. Graphically, that would make a lot of sense, because what would be going on then is simply this. You've got your y equals 2x function, right? And what you're trying to do, basically here, is at 3, you're trying to choose, a y-intercept for x squared plus c, such that it ends up going through here like that. So you're trying to make them join right here. And let's see here. What's the actual graph of? Let me draw the graph. So I've drawn the graph of y equals x squared plus c. X squared minus 3, actually. And y equals 2x, both in black. But what's the actual graph of the case-wise defined function here? So we've got x squared for x less than 3. So basically, it looks like this. Goes like that, comes up here, follows this guy, join right at that point, joins, and then this is going on here. So this is y equals f of x, all right? the part of the 2x function we're not using is this part, right? So like the formula for 2x goes on and on, but it's only applicable for x greater than 3. So this is what it takes to make a continuous function. So you have to move, basically we're moving the x squared graph down a bit from 0 in order so that it joins the 2x graph when they meet at 3. Then that makes it continuous. See, so I can draw my graph like so, continuous. So if you'd like a brief recap of what we did there, if you have a function which has cases, what you want to do is to make sure that the two cases glue together at the join point by taking the appropriate left and right limits, right? And this one is easy in the sense that both of these functions were unambiguous at the limit point, right? But there are other problems where you might have like some kind of indeterminate type for the limit from one side. And you'd actually have to do algebra like we did in problem 3 on the quiz in order to determine the limit, all right? But sorry, I haven't said anything terribly tricky today in terms of continuity. And continuity doesn't have to be tricky. Like it's really just a basic idea in here that we need. So tomorrow we will talk about this, the intermediate value theorem. I have squeeze and intermediate value theorem, but we've already talked about squeeze a bit. So I'll be focusing on intermediate value theorem tomorrow, which is kind of a neat theorem. It gives us a way to solve equations that we can't solve. That's weird, right? Anyway, thanks guys.